Hello mga ka-code konyo, welcome back. So for today, we are now going to discuss about third normal form or 3NF. So 3NF is it would mean that you accomplished or fulfilled already 1NF and 2NF, and make sure that there should be no transitive dependencies. So what is transitive dependencies? So let's take an example here. Let's say we have here a pet table, and then in our pet table we have this columns here: pet ID, pet, and owner ID. And notice that in our pet we have values here: puppy, dog, Matt, a cat of type cat, Lyra of type snake, Valentina of type snake, Cortana of type dog. So basically, our tables or our table is not actually doesn't have an atomic field. So therefore, we'll have to split them up into a separate field, making it like this one. So we have pet name, we have pet breed, and pet type. So we have here the pet name as puppy, and we could include a breed, let's say Dachshund, and for pet type, we have the dog. So when we talk about transitive dependency, it means that every attribute which is not a PK must depend on nothing but the primary key only. So I'm gonna show you later on the what it is, what it takes to be, or when is going to be a field, or a particular field is going to be or considered as a transitive key. So take note that based on our table, pet ID is actually determined by a pet type, which means that a pet is determined by a type like dog, a cat, and a pet type is actually determined by either a breed, which is, let's say, Dachshund, or a type would have like Dachshund, or a type dog would have Dachshund, a type dog would have Askal, or a type cat would have Persian, or a type um, python would be or would have snake, or a breed snake would be a python. No, a breed python would be a snake. Okay, and therefore it is also related that we can also relate that pet ID can be determined by a pet breed, or it determines pet breed, which is obviously they are actually all related. So when are we going to actually uh, how do I say this? Remove the transitive dependency. Before that, let's have here the updated table, which we now have fields like pet name, pet breed, pet type from this table, which we actually split the fields into three different fields. And as you can notice, we can observe na naatay repeating groups for pet breed and pet type. So with that, we are going to remove the uh, whatever field that causes data redundancy, or that is a repeating group. Therefore, pet breed and pet type will be removed from this table, and we are going to decompose or create another table for each of these fields. Okay, so now with this is our table pet and the breed table, which is we relate our table TBL breed with the primary key 110, 111, 112, and each of it assigned by a breed name. And we relate it to each pet in our pet table, which is a foreign key of this table. Okay, so this time we will do the same for pet type. So in our pet type, we have the table pet type, and then we also relate it to our table, which we have here. Each of our pet has assigned a pet type. Okay, but take note that in our table right here, though we are able to actually resolve the idea of the or resolve the issue about repeating groups, notice that for some reasons our table, okay, especially our pet, could be or would have assigned by a breed accurately, but not with the type in that sense. Why? Because we can actually assign Dakshan by a type with whatever type we are going to assign for it. Yeah. Okay, as you can notice in the Dakshan, which is a pet name Puppy, it has a pet breed of 110, which is a Dachshund, but in the pet type, notice that it is actually the assigned the foreign key for that is actually 203, which is actually a snake. And with the Persian is assigned to as a dinosaur. And Lyra, which is a python, is assigned to a type as a spider. So basically, there is data integrity there. No, there is data integrity problems there because we assigned uh, not appropriate type for our breed on that particular pet. So although we are able to again resolve the idea or the issue on repeating groups and data redundancy for breed and pet type, but the way we actually design our tables here are not good or not okay. So in that sense, we'll have to know that pet ID is actually pet ID determines pet type, meaning a pet ID is as a type, and then each of the type has actually breeds in it. So meaning each pet type would have breeds containing or parang assigned to a particular type. So we have like for dog type, we have Dachshund, we have Askal, we have Chihuahua, or any breed of that belongs to a dog type. The same with Persian, we have Siamese. For cat, we have Persian for cat. So with like sa snake for like cobra, for python and uh, another python and another snake. And of course, for spider, we have here a house spider and tarantula. Okay, so to actually resolve this conflict or to this data integrity problems, we are going to still separate decompose the table into different tables, the same as we have noticed here. We have here a breed table and then a type table. But this time, notice that our pet type is a table that actually directly connected to a breed because a breed is identified by a type, which is when we talk about Dachshund, Dachshund is actually assigned to a dog and Persian is actually assigned to a cat. And this would guarantee that whenever we assign a breed, let's say Dachshund, Persian, Python, to our pet, this would guarantee that the type is carried over. So meaning to say, if puppy is assigned to a breed of let's say Dachshund, then its type is 201, which is a dog. Then therefore, the type dog is actually carried over as you assign Dachshund as the breed of this particular pet, which is puppy. The same that applies to Persian, which is assigned to, let's say, Matt is assigned to a Persian, which is a Persian is assigned to 202 in pet type, which is a cat. And then for Lyra and for Valentina is assigned both to a Python breed name, which is both 203, which is 203 is a snake. So that is the essence of what we call transitive dependency. So we can assume that the we can say that the although pet breed and pet type are, let's say, functionally dependent to a pet, because again a pet determined by or identified by a breed or at the same time by a type, but because there is the data integrity within the tables as we create two tables, breed and type, and breed and type are both connected to pet table, then therefore we are not able to actually resolve data integrity problems. So with that, um, that is how that is one of the things about resolving transitive dependencies, meaning there should be no transitive dependencies within our table. And this is something like difficult to really uh, parang foresee in our table as we go along. Saka pa nato na siya ma-realize. So with this, again, pet type is defined. Pet breed is actually defined by a pet type or determines with the pet type, directly connected to a pet type, and a breed is directly connected to pet, which is a type is also already automatically carried over. Okay, so there you are about transitive dependencies. Another thing about transitive dependencies is that if you have the address in your table, notice that the address can be actually split into many different fields. You could have lot number, you could have block number, you could have street, you could have place, you could have village, you could have purok, you could have barangay, you could have district, you could have city, zip code, province, and country. So, meaning to say, a con a lot number, or let's say we'll start with the country. A country has many provinces assigned to it, and each province has zip code, and every zip code has different cities, and there are district belongs to a city, and of course in every district there are actually barangay belongs to it, and every barangay has purok assigned to it. The same with the village, especially if that is a village. Okay, and the phase and every phase has street number, block number, and lot number. So meaning to say, an address cannot be treated as one field in our table. So the best way to design our table with if we have address is we'll need to split, aside from splitting them up into a different fields, which causes data redundancy, or which actually occurred, parang mag-occur siya of more and more repeating groups. That is why we are going to create every table for each of this field for lot number, because lot number is going to repeat, block number is going to repeat probably. For street, like for an instance, we have Nara Street, we have Apple Street, we have um, Nara Street can be actually used several times in a different village. Phase can be used in a different and several village. They have phase 1, phase 2, phase 3. Purok can be used in a several barangay. So meaning there are two different barangays or three different barangays na pwede mag-assign of same purok, but they come in different barangay. As well as with the district, of course, or probably like that. So that is why if you are going to observe upon filling out a form in a bank, so you have their street number, you have the barangay, and even the city and province are actually separated because that is how it is. Okay, in order for, of course, no, to remove data redundancies and to organize your data, as well as that is one way to actually eradicate integrity problems. And that is why normalization is important. So I would leave this one to you. Uh, you can, it's your discretion whether to decide an address as a one field or split them up into different fields, or make it or create a separate table for each of the of this out of these fields. Okay, so I guess that would be all, and I thank you for listening and watching this video tutorial. Have a great day ahead, and bye bye.